Greetings. Welcome to my YouTube channel for training in electronics. Today's topic will be continuity testing, along with digital multimeters, along with breadboards. This is in the category of DC electronics, and this is designated topic number 1, presented by Frank Ko, also known as the KOGUY. So what is continuity? Continuity in electronics means that there is a path for electricity to flow. How do you test for continuity? Testing for continuity is most commonly done with a digital multimeter, DMM. So what is a DMM? DMM is the abbreviation for digital multimeter, and a digital multimeter is typically a handheld device with a digital display used for testing continuity, voltage, resistance, current, and a host of other functions depending upon the make and the model of the DMM. So some sample DMMs are shown to you in this view. The unit on the far left is a budget less than $10 special. The unit in orange red is one recommended throughout this particular video. Comes in under $17 from Amazon. And the unit here a little bit to the right has a few more functions shown, transistor functions, capacitor functions, a few other things. So something like this may run between $50 to $100. The unit on the far right is manufactured by Fluke. It's an American company and deemed by many people in the industry, electrical industry, as well as electronics industry, as being one of the best makes in terms of accuracy, durability, and it's reflected in the cost. These things can be $200 and up. Now, let's talk about test leads. So digital multimeter test leads are the wires that are used to be attached for very specific functions. They're attached to specific ports for testing various electronic properties. So standard test leads are shown here. The image on the left shows the probes. They're known as probes as well because they measure different physical quantities. So the test leads are shown with the protective caps on, and the image on the right shows the protective caps have been removed. So the cylindrical portion of the test leads contains something known as a banana connector, and this is the side that's typically connected to the multimeter. These caps that are removed from the probe ends, needle ends, are used to protect you from poking yourself when you are putting the cables into storage. But they have to be removed in order to do your electronics testing. So some sample test lead tips, they come in different kinds of tips. So if we look clockwise from the left, you'll see what's known as a standard tip, which is what's included with most multimeters. Then you can graduate to mini hooks. Mini hooks, if when you press the button on the back, presents a little hook out on this end and is used for grabbing wires very nicely. Then there's high voltage tips, and these are identified by the protective end on the probes, revealing very little metal. And then we also now have the alligator clips, and the alligator clips, these jaws can be open and they can grab onto some pretty heavy wires. Then there's the extended fine tip probes, and these extended fine tip probes are used commonly for measuring different pins of integrated circuits. Then, last but not least, are the tweezer tip test leads, and these are used in one hand and can test between the pins that are right on the ends of these leads. Continuity test ports. Is what are you going to connect the cables into? Well, if you look at it very carefully, this is described as the black probe goes into the COM port, the common port. So I have a black probe here, and into COM, a black probe into the COM, the black probe into the COM. And then the red probe goes into the red port. Now, you may have more than one red port, so you want to avoid the port that says 10A or milli A, anything with an A, a dedicated port, such as what's shown here and what's shown here in the large yellow one, or what's shown here in the red one marked 10A, or what's shown here marked 10A DC on the far left. They should be avoided. Now, we do have a recommended digital multimeter. The recommended digital multimeter is this model, Astro AI, and it has a big backlit display, NCV for non-contact voltage, uses two AA's, which is a lot easier to acquire than the typical 9-volt battery that goes into most digital multimeters, is true RMS. It's pretty good value for under $17, and I have the Amazon link at the end of the YouTube below. Okay, what we're going to do now is demonstrate how continuity testing is done with the digital multimeters. So with the digital multimeter, you connect red port to the red probe into the red port, black probe into the black port, and we will set this guy into continuity mode from off to here, the little sound symbol. That guy is ready to test for continuity, and the probe tips have been removed on this. And first thing you want to do is test for continuity in the test leads themselves. No good if you go to test for voltage and current and other things when the probes might not be connected properly on the ports, or maybe there's damage in the wire in the probes. So the very first thing you want to do with the probes is to test them for continuity. So red probe, black probe, continuity test mode. And when I go to touch these two together for a moment, you hear a beep tone. Okay, and you also may see the display change from over limit to 0 ohms, and it'll make a nice sound. On this particular fellow, what we're going to do is remove the protective cap on the cylinder end. These have what's known as banana connectors inside the cylinder. We'll connect the black to the common, as indicated before. Connect the red probe to the red port. Now remember, there's two red ports. You do not want to connect to something marked with an A. This is fine. We can measure milliamps here, but you want to avoid the 10 amp. So this is the correct red port for the red probe to plug into. Plug in there, like so, push in all the way firmly. And then on the probe end, we want to remove the protective cap. And the protective caps you set aside, and they are there to keep you from accidentally poking yourself. Now, once the probes are in place, this is ready for testing. Then and only then do you turn this on to continuity test mode. And that happens to be here. This is shown with a little sound symbol right there. And when I go to touch these two together, you should hear the characteristic beep. This particular multimeter will do something else interesting. I'll show you green light, and right there. Yeah, it's working. Continuity is working, and it flashes. All right, we will turn this off. Always remember to turn your machines into the off position anytime you are not using the probes. It keeps your batteries fresh longer. Okay. Okay. Something else I'd like to show you regarding your digital multimeter is you don't have to remove the test leads from the digital multimeter every time you want to use them. So you can leave the cylindrical ends on, the probes into the ports, and while they are left on, make sure the device is off. And when you are ready to wind these up, you can wind them up coil the wires around and make sure, yes, you have put on the protective tips so you're not going to poke yourself like so, like so. And these will go around your multimeter this way. And what's really nice at the end of it all is you have slots that will capture the probes and hold them in place. It's on the back. You just simply press down and it clips in place. And you do the same with the red probe. Press down and they clip in place. They hold very nicely. And as long as you have your caps on, you're not likely to poke yourself if you put this in your backpack or your toolkit. And when they're snapped in place, it keeps the cable from uncoiling. And so, yes, you can keep it in your toolkit or backpack in this fashion. It'll work out just fine. When we are ready to use them, remove them like so, unwind like so. There is a handy little stand on the back. The little screw is for removing this plate for changing your batteries when you are ready. And the little stand will help hold the multimeter at an angle so that you can see the display as you're using this on a bench. Okay, all right, great little machine. So next, what is a breadboard? A breadboard can be also called a protoboard for prototyping various electronic projects for experimentation. And we're going to proceed with a breadboard demonstration. Let me grab a couple of breadboards and show you a few things. So breadboards come in different sizes. We have the half-size board here. We have the full-length board here. And you'll see the breadboard is made up of many, many different holes. And there's numbers and letters on here to designate what each of those holes can be marked as in a legend. So we have up to 60 plus columns, and we have A, row, B, C, D, E, F, G, all the way to J. So like a bingo board, you can go to a very specific contact point, as each one of these holes represents a contact point. So these are breadboards. Now, what do we do with the breadboards? We typically, and they do come in different sizes, but we typically are going to connect electronic projects to them. And so some sample of electronic projects would be breadboards used in this fashion, and it shows a variety of different components that are hooked up on the breadboard, power supply, and then there's a timer chip that's in here with a couple of LEDs and capacitor. So breadboards can be used over and over again by putting on the components, taking the components off, and doing your experiments. This is really great. Now, as I've said, they do come in different sizes. These are the smallest ones. And if I go to move these out of the way, you can see, yes, we can have a slightly larger experimental board. And fundamentally what this is a couple of these put together onto a metal plate, and this gives you more space. The terminals on the metal plate are prefabricated and allow us to make connections, power connections onto the board for larger circuits. And then for even larger projects, there also happens to be even larger breadboards. And so even larger breadboards, as you can see here, will have the connecting binding, what we call binding posts for connecting power onto the board. And we have a number of different power rails that can be used to supply electricity to different electronic components that are on the board for a variety of different experiments. So where are you going to get the protoboard and some of these really wonderful electronic components from? Good question. So let me go ahead and answer that this way. The electronics program of your specific college may or may not provide you with project kit parts. If they do, great. If they don't, this is one that has worked out really, really well for my students for a number of years. Comes from a company called Bojack, and the link to this is in the Amazon at the end of the YouTube. You want to make sure that when you do acquire whatever electronic kit, whether it's this one or some other manufacturer, you want to make sure that the unit you get in the mail or from Amazon has the plastic blister pack on so that it gives you the assurance that this has never been opened. You want to be wary of the receiving a unit that does not have the blister pack, because this would tell you it's possible that the project kit has been opened, and because of there's a number of many small parts inside of this, there's a possibility that some of those parts may be missing, may have fallen out unintentionally, and you may not have a complete kit. So when you go to buy one, make sure that this does come, nicely wrapped in plastic. Now, what happens inside here is very interesting. Inside here, we do the unclip the locks and open this up. You will be able to see a wealth of different kinds of electronic components, and we will only focus our energies and interest at this point on the project board. So we'll go ahead and fish out the project board, our breadboard. There it is right there. And we'll show you what to do for continuity testing on this board. Most important thing you want to know about your breadboard is to learn the continuity pattern of all of these holes that are on the user side of the board. And it's really simple how things are laid out, but even easier to understand once you're able to see what happens inside the breadboard or what's underneath the surface. So what it is that we have here are a number of holes across here, and they're marked with a single red line. And that tells you that, and it's marked with a red plus. The blue line is marked with a blue negative. So very often these are called your power rails. So this would be the red power rail for positive. This is the blue power rail for negative. And this is what we connect the power to in order to supply electricity to components that sit on the board. Very much like what we have here. We have a power supply, and we're supplying power through the red rail and the power through the black rail, and they will feed the circuit in between. So how does that work? Well, the way it works on the power rails, the top and then the bottom, is very simply, there is a continuous strip of metal that goes from here to here. I've taken the back and peeled this off to show you what happens inside. And there is a row of a metal strip that connects all these holes on the blue rail, and then another metal strip that connects all the holes of the red rail. And they are shown on the backside as being continuous. What happens in this point, this area here, this is called the tie point area, where we tie specific components together. Like here, we've got very specific components and wires that are jumped together in the circuit part of your board. This is one example, and another example is right here. Again, power is supplied here and here, and then we have components that are connected to what we commonly call the tie points of our breadboard. And what we have going on here is, in each column of 5 holes, 5 tie points, there is continuity by virtue of the fact that we happen to have underneath here metal strip that connects 5 tie points together. And what specifically how that happens is right here. I've pulled one up, and this goes to show the little spring clips that are underneath each of these holes of the breadboard. And when we make a connection, let's say between A1, so B1, C1, D1, E1, this strip of these 5 holes here, there is a corresponding metal strip right underneath right here that connects these 5 points together. And the way that this works is demonstrated by this little spring clip. You connect a device by pushing a wire down into this hole, and it will have continuity with everything else that is in that group of 5 from here to here, as shown this way. And we can test that very, very quickly with our new continuity test function, like so. So from the digital multimeter, it's presently off. I've got the probes removed from the back. I'm going to remove the safety pins, protective cover. So now the probes are ready for making connection. What do you do before using this instrument on any electronics board for testing? You have to test the leads first. So we will switch this from the off to the continuity test position, which is indicated by the little sound symbol. Looks like a little speaker symbol. And the first thing we're going to do is we're going to test our leads. So the leads have already been connected red to red and black to black. And we will go ahead and test this way by touching. And it has a nice beep. So we know the test leads are good, which is great. And now we're going to test on the back side of the board these strips. So we said that these 5 are together. I'm going to hold on to this side and hold on to this side, and they beep. And I'm going to go here to here, and on this side, if I can get past the gummy stuff, yes, they beep very nicely, like so. And on the next group, over here to here, but not here to here. You can see that this group of 5 is indeed separate from this strip. Even the one right next to it has no continuity. But if I put the probe on the same strip, you'll hear the tone right there. And then the same is true for the power rails. On the power rail, if I pull this back just a little bit, it doesn't matter where on the blue set of holes we make a connection. If I push a wire down into this hole and I come along, stay with the blue rail, push a wire down here, they will have continuity. Now I'm going to do this on the back side where the metal strip is to show you. I will touch here, and then I will touch here, and it beeps. However, if I go to the lower strip here and I go to here, I hear the beep. But if I go one lower and one upper, there is no continuity. These 2 metal strips are completely independent of each other. Alternate, they're independent, but if I touch the same row, continuity there, touch here, continuity here. These upper power rails have no connection to the lower ones. So if I touch here, nothing, touch here, nothing. So these are not connected to the upper ones. If I go here and touch either one of these, again, nothing. However, if I come here and I touch this one and here, it beeps. However, if I touch here and here, no beep. This is what we expect to see on this side of the board because we can see the continuity pattern as guided by the visual of the little spring clips that are on the back side. What we're going to do next is confirm the continuity pattern on the breadboard itself. And that's very easily done in just a moment. Okay, for testing the board, this will go pretty quickly for us. I've already switched the multimeter into the continuity test mode. And again, before we do any type of testing of our experimental apparatus, always test your leads first. There, it's beeping, it's making confirmation that your test leads are working properly. So what I've done here is I've grabbed from your kit 2 of these jumper wires. These have metal pins on either end. I happen to have one red and one black. I grabbed the shortest ones possible. So I'm going to stick one of the metal pins of the red one into the red rail. Let's just stick it right on the very end. And I'm going to hold the metal tip of the other end of the jumper wire and make contact with the red probe and squeeze these 2 together between my pointer finger and my thumb. So now they're connected. And what I'm going to do with this black wire is I'm going to make a connection right here, 5 holes over on the same rail, red rail, and I'm going to touch the black with my thumb, and let's see if there is a nice beep tone, if this is making contact. And let's push this all the way down and do this. And sometimes if there happens to be some residue that's either in the contact point or on the probe itself, we will not be able to have good continuity. So let me just make sure, yes. So now I'm going to touch here. You can see, yes, we have continuity right there. Okay, and I'm going to move over to way down here on this part of the red rail. And so I want to check to see if those points here are all connected. And I'm now going to touch the metal end, and there we are. It's beeping very nicely. Now suppose I go all the way to the very end and touch. Yes, I have continuity. How about leaving this on the red rail and putting this somewhere on the blue rail? Does that just put this pin right in here, and I'm going to touch, and there should be no beep, and there is no beep. I have the pin between my thumb and my probe. There should be nothing. However, if I go to move the red wire over to the blue rail and connect this between my thumb and index finger again, right there, and now with the red jumper wire on one of the pins of the blue rail, the black wire on another pin of the blue rail, I'm going to touch. And there we go. We have continuity. I'm going to test the blue rail way over to here. And we should have continuity. There we are. It's touching. Suppose I go to the very end. There. So what that goes to prove, you should be able to prove to yourself, every one of those holes on the blue rail are continuous with each other, as evidenced by the back side of the breadboard, where this metal strip runs the full length of the board, one strip for the red rail, one strip for the blue rail. Now, are these power rails tied to each other? And the answer to that question is no, they should not be. But we're going to test. So right now, the red jumper wire is on the blue rail up here. I'm going to connect somewhere on the blue rail down here, and there should be no tone. And there is no tone whatsoever. If, however, I move my jumper wire to the blue rail down here, the black wire is on the jumper rail, blue jumper rail as well. Make sure this is nice and tight in my left hand, making contact. Hold tight, and now touch. And touch. There we are. We have continuity, showing that these holes have a metal strip that makes them continuous with each other there and all the way to the end of the blue rail over here. Let me just go ahead and touch. There we are. It buzzes nicely. Now, how about verifying the continuity pattern of these tie points? And according to the design, we should have these in groups of 5. No, this group of 5 has no continuity with this group of 5. They are separated on the top of the board with a groove, a channel, and the channel is used for mounting chips. So I happen to have a breadboard with a chip mounted, where one set of pins is on one side of the groove and another set of pins are on the other side of the groove. So they are not shorting each other out. And let me remove this for a moment. And let's go ahead and test these tie points. So I'm going to go to row 55, for example, and I'm going to go to another pin on row 55. So I got 2 of these wires in row 55, and I go to touch these together with one hand, and then now go to test this with the other hand. Bring this wire where you can see it. Hey, how about that? It shows us continuity. How about row 55 above the groove and row 55 below the groove? and we don't expect to hear a beep, and lo and behold, no beep. Okay, I'm just pressing the probe onto the bare wire that's somewhere on the board, but not plugged into any hole. Now, suppose I want to go to row 40, and I move this one also to row 40. So both of these are on row 40. And this is still touch my red probe, and I'm going to bring this over and touch the black probe. There, continuity, yes. And any one of these holds, like so, continuity, and move it up another one. Continuity, move it up right next to it. You want to get in there. Some of these pins, they're new, and sometimes they might be a little tight. Continuity. But how about if I go to row 35 and put this one on 36. Now, these are right next to each other. One's on 35, one's on 36. Do you think we're going to hear anything? Now, again, study this part of the board. You should not hear anything because each group of 5 is separate from each other. So while one is on 35 and one's on row 36, I'm going to touch here and go ahead, touch here. Even though they're right next to each other on the breadboard, we hear nothing. However, if I move one of the probes to 36, there, it beeps. So you want to verify this continuity pattern on your breadboard as from the top side as being consistent with what it is that you see, and hopefully now understand about continuity based on being able to see the back side of the board. And that concludes our discussion regarding continuity. Continuity, a complete path for electricity to flow. And we've talked about digital multimeters. We've talked about the leads. We've talked about the breadboards themselves. And the next opportunity we will have to meet up again on YouTube will be to talk about how to make your very first circuit on the breadboard. So if this video has been helpful to you, please go ahead and click the like button, a thumbs up, that'd be great, and hit subscribe if you'd like to. And the links for the kits and the multimeter are in the end of the YouTube. It's an affiliate link, so if you purchase it through Amazon from my link, it doesn't cost you any more than buying it from Amazon itself, but it gives this retired professor an opportunity to have half a cup of coffee maybe for every 10 meters that are sold. It's really minimal, but keeps this retired professor charged with caffeine and also be able to help produce more of these videos. So with that, thank you so much for your kind attention and take care.